Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from Dirac delta function related to integration based on properties of Dirac delta function, right? So here we have to find the value of this integral that is from minus infinity to infinity, and we have x square plus cos x and delta of 2x minus pi by 3, right? So here we'll solve this integral by making use of one important property of Dirac delta function. So let us start. So let us first call this integral as I, right? Now see, here we have in the integrand we have delta of 2x minus pi by 3, right? And while solving this integral, we have to take care of this term, right? So what we will do here, we'll make use of one important property of Dirac delta function, which says that delta of ax is equal to 1 over mod of a, and here we have delta of x, right? So this is an important property of Dirac delta function. So here delta of ax is equal to 1 over absolute value of a and delta of x, and provided a is not equal to 0, right? So we'll try to apply this property to this function, right? See, here we have 2, that is 2x. So what we will do, we'll take 2 common, and then we have here x minus pi over 6, right? So we'll write delta of 2x minus pi by 3 as delta of 2 times x minus pi by 6. Now see, this form is now similar to this one. So here this 2 is our a. So we can now write 1 over mod of 2, and we have delta of x minus pi by 6. So mod of 2 is simply 2. So we have half delta of x minus pi by 6, right? So now we can write this integral I as minus infinity to infinity, and here we have x square plus cos x, and for this term we have half delta of x minus pi by 6, and here we have dx, right? Now we can take half outside the integral. We have minus infinity to infinity x square plus cos x, and we have delta of x minus pi by 6, and here we have dx. So now let us take this function as f of x, right? So let us take f of x as x square plus cos x. And now see, this integral takes the form half, and we have minus infinity to infinity. Here we have f of x, and we have delta of x minus pi by 6 and dx, right? Okay, now here in order to evaluate this integral, let us take the definition of Dirac delta function, right? So now Dirac delta function is defined as integral that is minus infinity to infinity f of x and delta of x minus a dx, right? So Dirac delta function can also be defined like this or from this integral. So here the value of this integral is f of a, right? So it means this delta function, it acts on this function f of x at this point, that is a, that is x minus a 0. So we have x is equal to a, right? So this delta function has the value at this point x is equal to a only, right? And this point x is equal to a, it acts on this function f of x. That is, the value of the function at x is equal to a is the value of this integral. So now if we compare this integral with this one, then pi by 6 is the value of a, right? So x is equal to a. So here we have x minus pi by 6. So the value of a is pi by 6. So now the value of this function or this integral is half, and the value of this integral is the value of this function f of x at this point, that is pi by 6. So here we have f of pi by 6, right? So we have half, and now f of pi by 6 can be obtained from this expression. So here we have x square plus cos x. So we have pi by 6 square plus cos of pi by 6, right? So we can solve this expression. So we have half, and here we have pi square over 36 plus cos pi by 6, and cos pi by 6 is cos 30 degrees, that is equal to square root of 3 over 2, right? So the value of this integral I can be written as multiplying these two terms by half. So we have pi square over 72 plus square root of 3 over 4, right? So the value of this integral is given by this expression.